All right, so today's lesson is going to be on an introduction to the periodic table and what different pieces of the periodic table mean. So let's start with our three main categories on the periodic table. And we're going to start with the metalloids because the metalloids actually are our dividing factor on the periodic table, and they're going to have the properties of both the other two parts of the periodic table, and those are called the metals and the nonmetals. So properties of metals and nonmetals. So when we look at our periodic table, the metalloids are this stair-step line. So this dark stair-step line is our metalloids. Boron, silicon, germanium, arsenic. All right, so as we go through, those are the metalloids right here on that stair step. Now, to the left of the stair step, with the exception of hydrogen, we call those metals. So what are some basic properties of a metal? Metals are good conductors of heat and electricity. They are solid at room temperature with one exception. And that one exception is going to be mercury, which has the symbol Hg. They are malleable. Malleable meaning they are able to be hammered into a thin sheet. So think about aluminum foil. Aluminum foil is a thin sheet of aluminum. So they are malleable. They can be hammered into a thin sheet. They are ductile, meaning they can be drawn into a wire. They are drawn into a wire. Think about jewelry. Jewelry is made out of wire. Wire is a metal. All right, so they are able to be drawn into a wire. And they have a high tensile strength. So a high tensile strength, the ability not to break when pulled apart. So metals do not break easily when you try to pull on them. They stay in together. All right. We also have the nonmetals. So if the metalloids are the dividing factor on our periodic table, and to the left is the metals, the right of the metalloids, so this whole right section here, those are nonmetals, and hydrogen is also a nonmetal. Now, hydrogen, we'll really talk about why hydrogen is placed over in this column. Hydrogen is kind of one of those elements that really does a lot of different stuff. All right, but it is a nonmetal. What do we know about nonmetals? Nonmetals are poor conductors. All right, they are brittle when a solid. All right, and nonmetals can be a solid, a liquid, or a gas at room temperature. Now, it's really not until we get into AP chemistry that we really start to investigate why some nonmetals are solid while others are liquid and others are a gas at room temperature. All right, so if you come see me for AP chemistry, then we'll investigate that concept a little bit more at that time. So let's talk about the periodic table in terms of two vocabulary terms: the group and the period. So when you hear me say the word group, these are review terms because we've already talked about these before, but let's review them again. Group is the column. So this column is a group. This column is a group. The period are the rows. So the rows on the periodic table, each row, this is a row, is considered a period. We could then further subdivide our periodic table, and it's based upon the group. And if you remember from a previous lesson that the elements in this group all share the same number of valence electrons. The elements in this group all share the same number of valence electrons. Group 1A has 1 valence electron. Group 2A has 1, 2. 1, 2. 1, 2. So this whole group has 2 valence electrons. Now, because valence electrons are what's involved in bonding, valence electrons are going to also determine the properties. So group 1A, these are our alkali metals. And there is an exception here to group 1A. We call them the alkali metals, but we know that hydrogen is a non-metal, so it's not part of the alkali metals. It's still in this group because hydrogen has 1 valence electron. What do we know about alkali metals? They are the most reactive metals. They are never found in nature as pure elements. And they are going to react violently with water. All right, so these group 1A metals, they react very, very violently with water. So if we were to order lithium by itself or sodium by itself, it would actually come stored in oil, because if it was to even the water in the air around it could cause it to create this violent, extreme reaction. Group 2A. These are our alkaline earth metals. All right, and group 2A is right here, 2 valence electrons. All right, they are reactive, but not quite as reactive as group 1A. And they have 2 valence electrons, 2 VE for valence electrons. And group 1A, let's talk about their valence electrons. Let's write that down. They have 1 valence electron. So they are still pretty reactive. Let's look at group 7A. What do we know about group 7A? Here's group 7A, also called group 17 sometimes. All right, fluorine, chlorine, bromine, iodine, that whole group. Group 7A. They are the most reactive nonmetals. They are toxic when by themselves. They are never found as a pure elements, though. All right, so if they're not found as pure elements, what does that mean? Most of these are what we call diatomic. And there are 7 diatomic elements. Not all 7 diatomic elements are found in group 7A, but there are 7 of them. So let's look real quick about the 7 diatomic elements. And the way that I remember the diatomic elements is through our acronym HUNCL-BRIF. HUNCL-BRIF. Hydrogen by itself is H2. Oxygen, when not in a compound, is O2. Nitrogen, when not in a compound, is N2. Chlorine, when not in a compound, is CO2. Bromine, when not in a compound, is Br2. Iodine is I2, and fluorine is F2 when not in compounds. Di, meaning 2 atomic atoms, 2 atoms. So hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine all have 2 of the same atoms when they are not in a compound. All right, let's look at group A, the noble gases. All right, the noble gas is group 8A, and that's going to be this very last column here. All right, they are very last column here. They are inert. And they are a gas. All right, they are found in the state of matter, a gas. That's why we call them a noble gas. So what does inert mean? Inert means they do not react. And as in chemistry, the only exception or the only rule in chemistry is there are no rules. So this do not react, there is an exception to that. Xenon is actually reactive, but we're not going to get into that until we get into AP chemistry. So for the purposes of our class, we're going to say they do not react, that they are all inert gases. They do have 8 valence electrons, and again, we have to have exceptions because the only rule in chemistry is there are no rules. So the exception to the 8 valence electron rule is helium, which has 2 valence electrons. So let's take a look at our periodic table. Helium is right here. So it has 1, 2 valence electrons. The rest of these have 8. Because when we count our valence electrons, they come from the S and the P sublevels. So 1, 2, skip the D sublevel, go back to the P, 3, 4, 5, 6, 7, 8. So they have 8. Finally, let's go back and add in for our group 7A. They have 7 valence electrons, so we'll add that into our notes as well. All right, 2 more things that we're going to look at real quickly here on our periodic table. And that's going to be these bottom 2 portions. These are still metals, but we can break them down into what we call the lanthanides and the actinides. So the lanthanides, this is our sublevel 4F. And if you remember, the 4F is this top row. And the lanthanides are going to have properties similar to the alkaline earth metals. All right, what about this bottom row? This bottom row is the 5F row, and we call those the actinides. And these are radioactive. Now, there are other elements that are not an actinide, which are radioactive, but the actinides, for the most part, are the majority of the radioactive elements.